In the previous video, we saw how product law was applied to a product of two numbers with the same base. Let's try dividing two numbers with the same base. 3 raised to 5 divided by 3 raised to 3. Again, remember, we are performing operations on numbers with the same base. Here, the base of both the numbers is 3. There are two ways in which we can solve this. 3 raised to 5 can be written as a product of 5 threes. So this would equal 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. And 3 raised to 3 can be written as 3 multiplied by 3 multiplied by 3. Looking at this expression, we can cancel out 3 threes from the numerator and the denominator, and what we are left with is 3 multiplied by 3. This can be written as 3 raised to 2. Now let's look at a simpler way. The base in both the cases is 3. So we can directly write 3 raised to 5 divided by 3 raised to 3 as 3 raised to 5 minus 3. So we kept the base as 3 and subtracted the exponents over the base. This method in which we can subtract the exponents of two numbers with the same base is called the quotient law. This also gives us the same answer, 3 raised to 2. So we can generalize the quotient law by saying a raised to m divided by a raised to n equals a raised to m minus n. But wait, we missed something important. In this example, this is called the dividend and this is called the divisor. Observe that the power of the dividend is greater than the power of the divisor. Well, here's another example to understand why this observation is important. 7 raised to 2 divided by 7 raised to 4. In this case, notice that the power of the dividend is lower than the power of the divisor. 2 is less than 4. There are two ways of solving this example too. This would equal 7 multiplied by 7 as the exponent is 2, and this would equal 7 multiplied by 7 multiplied by 7 multiplied by 7 as the power is 4. Cancelling out two 7s from the numerator and the denominator, we get the answer as 1 divided by 7 raised to 2. The easier way to get to this answer is by writing this directly as 1 divided by 7 raised to 4 minus 2. This is also the quotient law, but it was a little different this time. We subtracted the exponents, yes, but this time we kept the number in the denominator. We wrote it as 1 divided by 7 raised to 4 minus 2. This 7 is same as the base in both cases, and we subtracted the exponents over it. This gives us 1 divided by 7 raised to 2, the same answer we got earlier. So the quotient law says a raised to m divided by a raised to n gives us 1 divided by a raised to n minus m, with a condition that says m less than n. In the earlier case, we wrote m minus n. This time we wrote n minus m, but under a 1. One easy way to remember this is that no matter what, you will always get a positive exponent. In the second example, to get a positive exponent, we had to subtract 2 from 4, hence n minus m. For the earlier formula of quotient law, the condition says that m is greater than n. If the exponent of the dividend is higher, we simply write it like this. If the exponent of the dividend is smaller, we write it as 1 divided by this. This law is satisfied in all cases except when a is equal to 0, because we cannot have 0 in the denominator. So a is not equal to 0 is another condition we should remember. The examples will help you understand better. Let's try solving 6 raised to 9 divided by 6 raised to 3. In this case, the base is the same and the exponent of the dividend is higher. So we are looking at the first case here. Hence, we write this as 6 raised to 9 minus 3 using the quotient law. That gives us 6 raised to 6. Here's our second example. 17 raised to 12 divided by 17 raised to 21. Here, the exponent of the dividend is lower than the exponent of the divisor. Hence, we use this formula and write it as 1 divided by 17 raised to 21 minus 12, which gives us 1 divided by 17 raised to 9. Observe that the formulae are made in such a way that we always get a positive exponent. Now try dividing 4 raised to 4 by 3 raised to 2. Can this be solved using the quotient law? No, since the base in both the cases is different. So the quotient law says that while dividing numbers with the same base, subtract their exponents. If you already know what negative exponents are, then this one formula would suffice. But we use this second formula since we haven't come across that topic yet.